Earlier we discussed the frame of references. Frame of references are the set of coordinate system attached to the body which are either rest or moving. If these frame of references are stationary or moving with a uniform velocity, then we say these frame of references are the inertial frame of references. While a frame of reference which is accelerated, that are known as the non-inertial frame of references. This pseudo force which we are discussing here, this come in picture when we are measuring in a non-inertial frames or accelerated frame of references. For example, suppose these are the two frame of references. This is S and this is S dash. This is X, Y, Z, X, Y, Z. There is a point P which is moving, point P or mass body which is moving with acceleration A. This A acceleration is measured by S and S dash. Suppose both this S and S dash are inertial frame of references. That means these are non-accelerated frame of references. Non-accelerated. So we can write the equation that acceleration of P with respect to S dash, it is equal to, we know that the acceleration A of the body P with respect to S is A. Then we can find what is the acceleration of this particle with respect to S dash, which is moving with a constant velocity or is at rest. We can write APS dash equal to APS plus ASS dash. These are X vector quantity. Because both are S and S dash are the inertial frame of references, that means they are non-accelerated frame of references, we can say ASS dash is equal to 0. That means when there is no acceleration in S and S dash, so their relative acceleration will be 0, and we can write APS dash equal to APS. Now we take another case if S dash is accelerating. So second case we are taking these are the two frame of references. This is S and this is S dash. This S dash is moving with an acceleration A naught, suppose, and there is a point P which is moving with acceleration A when measured from frame of reference S. So we can write acceleration of particle P with respect to frame of reference S equal to A. Then we have to find what is the acceleration of this particle when we are measuring with respect to S dash. So we can write acceleration of P with respect to S dash equal to acceleration of P with respect to S plus acceleration of S with respect to S dash. It is equal to, this is A, we have given here, plus we have saying this is the acceleration of S dash is A0 with respect to S. So we can write acceleration of S dash with respect to S is A. Here it is SS dash. So we can write SS dash, that is we are inverting the vector, we will get minus A. So we can write here it is minus A0. That is equal to A minus A0. So we can write multiplying by M, mass of the particle P. This is MAPS dash equal to MA minus MA0. This MA is the force of the particle when measured from the frame S, which is a inertial frame of reference. So we can write it is F minus MA0. So acceleration of particle P with respect to an accelerated frame of reference, say S dash, it will be equal to F minus ma0 by m. Here the term minus ma0, this is the pseudo force. This term is to be used when we have to apply the Newton's law of motion in an non-inertial frame of reference. So in brief or in summary way, we can say that Newton's law of motion will be F equal to m gives acceleration for the inertial frame of reference. Inertial frame of reference are those references which are non-accelerated frame of references, non-accelerated. But if frame of reference in which we are measuring the acceleration, in that case acceleration will be F minus ma0 by m. This minus ma0 we have to include. This is the pseudo force in case frame of references are non-inertial. So in using the law of motion in non-inertial frame of references, that means the frame of references which are accelerated, we have to use this minus ma0, the pseudo force, then the equation becomes usable in the non-inertial frame of references.